Have you ever wanted to build scalable solutions without managing the infrastructure? Well, Azure App Services, it is the answer. In this course, we'll be beginning from the basics of Azure App Services up to some of the most advanced features like deployment slots, containers, and how to scale Azure App Services. Then, we'll cover how we can build solutions that can scale to that global scale that some of the solutions out there are going to need. So they need to be globally distributed. We're going to see how we can use Traffic Manager, Front Door, Azure CDN to achieve this. To make the most of this course, you should be familiar with Microsoft Azure and also have some experience with one of the supported programming languages of the Azure App Service. It's also recommended that you're familiar with Visual Studio and all the tooling around it. All the demonstrations that I will create for this course are basic implementations. I'm using Visual Studio Code, so that, you can focus on the core topics of the course, which is app service, instead of understanding the complexity of a business case of an app that, does a lot of things and has a very complex architecture. A big disclaimer here is that Microsoft is constantly updating Microsoft Azure. I usually treat Azure as like a moving target. If you see a different interface in the portal when you're trying to replicate my demos than the one that you find in the videos, you should consider that to be normal, because probably when I recorded the videos was already a few weeks ago, and what you're seeing today, it is slightly different. Usually it's not something that is going to be a huge difference. You can figure it out. If not, look, just go for the comment, and I will try to help you on that. So a good reference point also for you is also check the Azure documentation, and you can find that today on learn.microsoft.com/Azure, and where you can find lots of other good documentation. And sometimes when you have those issues that you're not looking at the right interface, just go there. Probably there's an example there that can guide you and help you on that too. In order for you to follow the demos, you will need Microsoft Azure subscriptions. You have to grab some kind of subscription. It is also recommended that you have an instance of Visual Studio. I just recommend, 2022 Community Edition. It's the most recent one. Community is free for learning, so you can just use that. Or even Visual Studio Code. Like I said, our workloads are pretty simple in here, so we're not going to do some very complex things that will require, Visual Studio, the full version of Visual Studio. So the Community Edition or Code are more than enough. I also do some demos where I use Azure Storage Explorer and also Postman. So you can also check those other tools. All the tools that I have here, excluding the Azure subscription, they are free. But even the Azure subscription, you can also do a free trial on that. How a better way to start than just to start to give a small overview about the Azure App Services. And, for this, I always like to show first, how can you run HTTP-based applications in Azure? And whoa, this is a world by itself. We have several services that are capable of handling such kind of demand. Virtual machines is probably the most obvious one. Basically, they can run almost every service, every workload that we can have. So yeah, sure, they can just run web applications, HTTP-based applications like an API. Then app services, that's the one that we're going to focus on this course. So we're going to have loads of slides and demos about the app service, but you can also run them in functions, especially if it's just an API. So there is HTTP triggered functions that we can also use. Even if it's not the focus of this course, we're also going to touch, just to make a reference about functions later in this overview. And then, of course, you can also run this in compute containers. And whoa, another world. Compute containers, we have several options in terms of Azure services to run containers. Of course, we can run containers inside virtual machines too, sure, but we also have ACI, so Azure Container Instances. We have Service Fabric, we have Azure Container Apps, and we have AKS, so Azure Kubernetes Services. Some of those are what we call container orchestrators. So to run, very large volumes of hosts and then running a very complex infrastructure around containers, usually using something like microservices approaches. So this is, just some of the services that are able to run HTTP-based applications in Azure. But of course, let's focus here on the Azure App Service. And look, what is the Azure App Service? It is capable of running HTTP-based applications. It hosts web applications or a REST API, a mobile backend, so something around that. Supports multiple languages and frameworks. We have some more info on that later. We can also run containers on the app service, by the way. That's also something that, we can run a simple container or using Docker Compose containers. We also support Windows and Linux workloads. So when you're running the Azure App Service under the hood, there is some compute. We can just say they are virtual machines. And those are running Windows or they are running Linux. And we then need to make a choice between one or the other, based on what kind of language, what kind of framework, what kind of prereqs does our application needs. For example, if you're running a traditional .NET application, well, you really need to choose Windows. That is the only one that can handle .NET. If we're talking about .NET Core or .NET 6, as you know, this can also run on Linux. So then we have choices. We can run Windows or Linux. We can choose the one that we want to run because both of them are supported. Both of them run pretty well. And then we have other workloads like Python, one of the latest versions of Python, the latest versions of PHP that Microsoft took the decision of only run those in Linux workloads. I'm not saying that they don't run on Windows because, of course, they do. But on the Azure App Service, Microsoft took the decision that we only support this in Linux workloads. So that's, you have to choose, and depending on usually the framework, you have more or less options to choose from. We also have loads of templates available on the marketplace. I usually demo this in my classes by just showing my students, hey, do you want to build, imagine a WordPress website? Let's just check this out. There's a template for WordPress that just creates all the infrastructure around that on the app service. And of course, you just need to configure, WordPress and then put some templates, put some data, and very quickly you have your website up and running. We also support for continuous integration and continuous deployment using, for example, GitHub and Azure DevOps. Again, I'm not saying that, you can only do this with GitHub and Azure DevOps. For sure not. If you have Jenkins, yeah, sure, you can still do it. But it's just the integration that we have with those two services. They're owned by Microsoft. So, Microsoft works a lot to integrate all this very, very well with the Azure App Service. And of course, we also have integration with Visual Studio Code. So you can just, build and coding your app on Visual Studio or Code and very quickly say, hey, I want to deploy this to Azure App Service and just test it live and even connecting your app, and doing a debug live on the Azure App Service. So there's lots of options that we have here. So very interesting features here. And of course, like I said, multiple languages and frameworks. We support a bunch of languages and framework like .NET, .NET Core, Java, Node.js, PHP, Python, Ruby, Go. So all of those are, languages and frameworks that are supported by the Azure App Service. Also important, what about scalability and high availability? There's two big topics, correct? So we want our applications to be able to be hosted in a service that it is scalable. And of course, it is highly available. Let's start with highly available. We guarantee 99.95% of uptime because, the Azure App Service has that SLA. So we guarantee this when we're using the Azure App Service. Also, we host our app anywhere in the Microsoft Global Data Center infrastructure because the Azure App Service, it is a service that is considered to be a core service. So that means it is available in all the regions that are currently in GA. GA, by the way, stands for general availability. And in terms of scalability, how big can this scale? Well, depending, of course, on the size, the tier that you choose, but you can scale up to 100 instances. So that's already a really large web application or API that needs 100 instances. Some just other features that we have. We can also use this, to run serverless code. We also have integration with other Azure services like Traffic Manager, Front Door, CDN. We can create IP restrictions. We can configure auto-scaling. We can add custom domains or using SSL TLS, using deployment slots. And of course, we can also isolate our app service in a private virtual network. So all of those, or most of this here, we're going to see in our course, and we're going to do some demos in how to customize and then what the features can give us. Now it's time to talk about Azure App Service plans. So in the app service, all the applications, they need to run inside an Azure App Service plan. The App Service plan will define the set of compute resources where that web application or API app will run. If we want to do a small comparison with the traditional on-prem technology, this is the server farm. So a set of virtual machines that we have where we run our websites. We can also have one or more applications running in the same computing resources, or in this case here, in the same Azure App Service plan. The App Service plan defines the operating system, if it's Windows or Linux, in which region it is running, the number of instances that it composed that service plan, the size of them, and of course the pricing tier. And we're going to touch on the pricing tiers pretty deeply, and we're going to see that, going from one tier to the other might make big changes in terms of the features that you have available or not. So, but let's just go here first and let's talk about the app service plan. So we have this empty app service plan, and now we can just add, several applications. As you can see here, they're just going to be added. And in this case, we're running 2, 3, 10 applications. So there's not exactly a limit for the number of web applications you can run on a dedicated app service plan. But of course, there are some best practices in terms of number of the applications that you're able to run in an app service plan. In the documentation, in the official documentation, you can find several documents that they talk about a little bit about that. But of course, it always depends on what is the size of your web applications. In my specific case, I have an app service plan that has way more web apps than the ones that they say on the official documentation. And why is that? Well, because they're really, really small, And so, of course, they get out of, that regular web app that they need to kind of use as a benchmark to just give you a number. So just watch out for that. That's just a number based on a benchmark. But of course, if you have very large web applications, you might want to have even more than one per app service plan. Okay, so that might even happen. I also have several customers with that example. Talking about pricing tiers. So we have two big different tiers. We have shared pricing tiers and dedicated pricing tiers. Let's start with the shared ones. If we go for the shared ones, we have one that's called free, and the other one, it's called shared. Okay, so it has the same name. The free, as the name says, it's free. You have 60 compute minutes a day, 1 gig of RAM, 1 gig of storage. Not that much to say over there. The shared, you start to pay. You get more compute minutes a day, and you get extra features, like, for example, the possibility to have this with custom domains. So instead of creating an app that is going to be called something.azurewebsites.net and you're basically stuck with that, you can also say, no, mycompany.com. So that's a big advantage of the shared pricing tier. But if we go for the dedicated compute, so we start with the basic tier. And the basic tier gives me custom domains, but now with the possibility to use HTTPS. And believe me, you want to use HTTPS nowadays on your application that is exposed on the internet. You can also scale this to 3 instances in each one of the instances, and you can get this to have up to 10 gigs of storage. That storage that you see there, by the way, is to host your web applications, your APIs. And usually, let's be honest, it's just code. So it's not that much space, because if we have images or data, well, we have like blob storage to host the images or a CDN. For the data, well, usually we have a database for that kind of stuff. It's out of this. This is just the web application. And we have 3 tiers here, B1, B2, B3. The only difference is, more compute capacity, more RAM, and that's it. And each one of them, if I just choose, for example, I want a B1. And now I can say I want this with 2 instances or 3 instances, but it's manual scaling. So I need to go there myself and, just tweak this myself. This is where we can go for something like the standard tier. If you go for the standard tier, you start to get extra features, like, for example, custom domains with SSL, which is the same, but now we can go up to 10 instances. And 10 instances, okay, more than 3, the ones before, but now the big difference is we have autoscaling. And we're going to demo this later on, but we can, just configure a rule to scale out, so to get more instances, and also to scale in, so to get less instances in our app service. We have 50 gigs of storage, we have up to 5 staging slots, traffic manager support, and then the sizes S1, S2, and S3 are the same sizes as we had before in the basic tier. We also have other things like, for example, Premium V2, for example, where, we get still having custom domains with SSL. We have auto scaling that officially can go up to 20 instances, but in some regions we can even get to 30, but I didn't want it, just to put that here in written. We have 250 gigs of storage, up to 20 staging slots, and also traffic manager support. So, yeah, very cool things in here. And also, if we go for something called Premium V3, which is, one of the latest versions that we have here, we have all the premium V2 features, and we have a minimal of 190 ACUs per virtual CPU. And we also have, by the way, here, an important part. This one here always has 30 instances, so you can go up to 30 instances. And if you see the P1 V3, the P2 V3, and the P3 V3, which are the sizes of the virtual machines, they are way bigger, okay, than the previous ones, because these ones here are way more capable. They're way more modern hardware running this. So again, very, very big advantages on that end if we have an application, of course, that requires such a compute. Then we also touch base here on something called the isolated V2, also known as App Service Environment. And the big feature that we have with this is the network isolation. So if we create our application using this tier, we get this network isolation. So what this means? Well, it means that instead of having always a public endpoint like something.azurewebsites.net, we can have our own private IP address or even private domain from just a VNet. So when you create this, you say, hey, this is going to be created on that VNet over there. So that's a big advantage. And, lots of customers, they choose this exact tier because of this, but also because you need to have more instances than the 30 than Premium V3 gives you. So you can also go to this. And also more storage. Instead of 250 gigs, we can go up to 1 tera of storage. The storage, to be honest, is not very common to have this kind of needs, but you get more storage. The auto scaling up to 100 instances, usually, to be honest, is also not usually a big reason, but, again, we can have more than 30 instances. So how do you create your app service plan? So you can create app service plans basically in 4 different ways. Just go on the Azure portal. If you're just trying something out, it's cool. Just easily go there, just create something. but it's not something that you can easily repeat. And especially you can not easily automate. So that we have ARM templates, JSON templates, or Bicep templates, PowerShell, or even Azure CLI. So all of them are great options for this. There's just some examples here. For example, if you plan to do this with Azure CLI, so this is just an example of some code that you can write to achieve that. So Azure App Service plan create, and then you just need to pass some arguments and some values like resource group, the location, the name, and what is the SKU that you want to use on this. And if you see the same thing to do, but with PowerShell, very similar to be totally honest. But of course here we have the new commandlet. You use the verb new and then Azure App Service plan, resource group, and you just put the name of the resource group, the name for the app service plan, the location, the tier. So here is the difference is not SKU, it's tier, and then the worker size. So you can have this here. And of course, this will then also create an app service plan using PowerShell. So let's create some Azure App Service plans and see all the main features available for that. We're in the Azure portal, and let me just search here for App Service Plans. So just type App Service Plans. They should show up here, and we just select that. As you can see, I already have some in this subscriptions, but I'll just click here, Create, in order for me to create another app service plan. And as you can see here, I have some project details to select. I can select here what subscription I want to run on this to, in which resource group I want to do that. And I'll just call this LinkedIn Learning Demo. That will be my name here. And then I will also choose a name for my plans. I'll just say LinkedIn Learning Demo App Service Plan. And then, of course, some more things that we need to select here. What is the operating system? I can choose Linux or Windows. What is the region that I want to choose? I can choose, for example, East US. Let's just say this. And then, of course, what is the pricing plan? And when we click change the size, you can see here all the sizes that we previously mentioned. Like for dev and test, okay, we have the free. This is the basic. Okay, if we click see additional ones, you can see the B2 and the B3s that I told you about. If we go to production and we click see all the recommendations, so see there's lots and lots of them in here, and also the isolated ones where we can choose that. I'll go for a P1 V2. That is the one that I want. If you scroll down in this screen, you can see custom domains, autoscaling, staging slots, daily backups, and traffic manager as the features that we have. And then, of course, we just hit review and create. If you wanted, the other step was to put tags on it. Tags are important, but we're not here to talk about tags now. So let's just do this and then let's hit create. So now it's just, a little bit the waiting game. Creating an app service plan doesn't take almost any time. So let's just wait a little bit to see if this deploys. There you go. See, that didn't took that much of the time. We can click go to resource and we just go directly into our resource. In this, we can hit here under settings, apps. And if you go for apps, you see all the apps that I have deployed there, which right now, look, there's nothing there yet, no results. But in one of the further demos, we will just start to add some more web applications onto this plan. So what about Logic Apps, and how can Logic Apps help you with your workloads? So just a small overview here about Logic Apps. We build Logic Apps to automate, business workflows. We can schedule, we can automate, we can orchestrate tasks. All this using a no-code experience, and that's the big plus of this. So you don't need to be a developer in order to create those workflows, grab data from a SQL database, then send that data into Cosmos DB, or getting some pictures from blob storage and then copy those pictures into another service, getting data from, a social network and then send that to cognitive services and understand, is that post with a good sentiment, bad sentiment about your company, your organization. And then, just add this to Salesforce, for example. So all this is some things that we can achieve using this no-code experience with Logic Apps. All this also using, serverless model. So there's no infrastructure for you to manage, like a virtual machine where you need to patch, you need to think about security of that infrastructure. So we don't have that. And of course, fully managed. And just an example, like schedule a recurring task, for example, that you need to run multiple times a day. Something simple that, sometimes we need to build. And sometimes I see customers, building virtual machines for this kind of things, where they could just build a very, very simple Logic Apps and, they will be happier with the output of that. So key terms that we have here, it will be like the Logic App. Well, that's the Logic App itself. Then we also have the workflow, which basically is the series of steps that define a task, a business process, or workload. Each workflow starts with what we call a trigger. That's what, starts all those steps that we have here. So the trigger will be always the first step there. Then we also have actions, which basically subsequent step in the workflow that follows the trigger. Will just, execute a certain task and then another task. So we have those actions, and we have connectors. So connectors, we have basically built-in connectors and managed connectors. The built-in connectors are, just like the name says, built-in. So the ones that come by default. And we already have literally hundreds of built-in connectors for Logic Apps. We can reach services that are Microsoft, Azure, 365, Dynamics, all of that. But we can also reach third-party services. I was just giving the example of Salesforce before. So there's a connector for that. There's a connector for the most known social networks. So you can just use those, and usually those connectors, they come with a bunch of triggers, a bunch of tasks that you can use in your workflows, in your Logic Apps. Even if you need, to get on-prem data, you can always do this. And usually we do this via integration accounts also, to get data and to do like exchange message that follow electronic data interchange. So IDI, enterprise application integration, AS2, Edifac, X12. So all of those protocols also usually use this via this integration account. So how do you create the new Logic App? Well, there's no code experience needed, so you don't need to have coding experience. You can just use the Azure portal, and there is a UI for you to use. And of course, we also have extensions, and we can also use Visual Studio and Visual Studio Code and do this straight from those applications, which, to be totally honest, it's a little bit my preference, because then we can just source save all the Logic App. So it's something that you always want to have under like source control system, like Git on GitHub or DevOps repos, something like that. Okay, so with larger Logic Apps, you can easily create some workflows automating several tasks. Right now, what I'm going to do is I'll just have a look on how to create here a simple Logic App. So in order to do this, let's just do this by clicking on Create a Resource, and let's select Logic App. Like I told you, there is always different ways of creating resources. This is just another one. So let's click Create, and, again, subscription. What is the resource group where I want to create this? I already have one here called LinkedIn Learning. That's the one that I'm going to use. And let's just say if I will just call this LinkedIn Learning Demo logic app. And let's just see if this one here, it is available. It is, because this, by the way, it needs to be unique. So that is something that we need to be careful on. And then, I'll publish, that will be a workflow in which region I want. I'll go for East US. And then what is the plan time? So there's like several plans for this. Standard is more for enterprise level, but we also have consumption for entry level, and even, small enterprise workloads. Why not? Something that doesn't require all that compute capacity that, the standard will give you. And then I'll just go for consumption, and then pretty much it just review and create. And this here, it will create the logic app. So I also need to hit create again. This will just create the logic app. Now that we have the infrastructure of the logic app created, we need to create, what is going to be the workflow of our logic app. So let's just go to the resource. This is straight into something that we call the logic app designer. It will show you the wizard, because this is the first time that we open this specific logic app. So you can start with a common trigger if you want, or we can start with some templates. So this templates, it's like the name says, it's already have the workflow built all for you. And, you could search this yourselves later on. But in my case, I just go for blank logic app. So this will be, something, I don't have anything in here, and I just want to build something from scratch. And so now I can, just go here and search. Search for what? So I need to search is for a trigger, because like we mentioned before, every logic app starts with a trigger. So we need to have something that will just say, hey, this logic app will run. So let's just get started here, and let's click on all. And, when we click on all, there's like several here. Could just do like an HTTP request or some event on an FTP server, RSS feeds, something around SharePoint. But in my case, let's just go build something, simple, like a trigger that is going to be based on a schedule. Then we have two types of schedule. I'll go with recurrence. And, the only thing that I want to do here is just do this, I don't know, like every day. We have here some settings if you want to put like a track RD and, some more things into this. But let's just go with this. This will be our trigger. Every day, it will execute. You can add some more parameters in here so that we have like this, start time. Yeah, usually when we do this, we have something like a start time for this, but I'm not even going to put this here. Let's just do this. And then after that, occurs, I need to add another action. And this action will be based on the connectors that I have in another action that I'm going to have here. And as you can see, if we go to the all here, and this usually takes a little bit of time. There you go. And as you can see here, there are tons. And when I say look at the slider there, like literally tons of different connectors that provide me different actions into this. Let's just imagine you want to send an email. So if you just search for email, or better yet, if I search for Outlook, because Outlook is one of the connectors that we have, so Outlook.com, and then just on Outlook.com, see, I have, again, several actions that I can do. And one of those actions will be this one here. Send an email. And if I click on this, now I will need to sign in with an Outlook account to create a profile. So I'm just, doing that, taking care of that right now. And when I do that, what happens is, and I already did this, it's just, to be honest, a very traditional sign-in progress. I can just type here, hey, what is the email where you want to send this message to? Again, this could come from a variable. This has variables. There's lots of things that we can have this. And there's like test email. And then you can have a body here. This is the email body And of course, again, we could put some things that, and like variables and data that comes from the top of the workflow, importance of the email, high, low, normal. I'll just keep it at normal. And so this is what we can do with this. And if we just press save, now this has been saved and this is running right now. So if you want, you can run the trigger, so you can force the trigger now to run. But this is it. This is how you build a logic app. And of course, look, there's plenty of more than we could talk in here. I can also get in here, and if we go to the all section, and if we scroll a little bit here, this part, okay, as you can see, like Key Vault, cognitive services, there are literally, loads of different options in here. And of course, there's also selectors. You can just say, hey, no, look, if we go to the built-in ones, you can have your controls. You can have batch to execute this in batch. If I go to control, you see conditions for eaches, switches, until. So there's literally lots and lots of options that we have here on Logic Apps to really build a big workflow with loads of features on this. Okay, so time to talk about Azure Functions. One of my favorite services after App Services, I have to confess. So this is what we call serverless compute service to run code on demand. All this without provisioning or having to manage an infrastructure. And if you run this under the consumption mode, we don't even need to worry about scaling to the number of instances. The service will just take care of that. So if you have more load, more instances are needed, sure, the service will take care of this. So in resume serverless event-based compute, this runs based on the app service. This is why I'm making a reference to functions in this course. We have auto scaling based on the workload, no wasted resources. You pay for what you use when using the consumption model. So the consumption model also has that advantage. It's not just the scaling that we don't need to worry about. Is if you're not using this, you're not paying. So that's also a big advantage. In some types of workloads, this can be way less expensive than having a dedicated, infrastructure ready for you. So if we go this in some scenarios, I always like to give some scenarios about this. Support an API, for example, if you want to do that. Serverless web architectures, that's another one. Run a scheduled task. Some examples here, like do some image, video processing, payment processing, support an API, CRUD event. And then you might ask, Tiago, but 2 videos ago we talked about Logic Apps, which, we also talk about that scheduled tasks and all of those things. It's not exactly the same, but very similar when to use one or the other. Well, there's a big major difference. This is a coding experience required service. So you need to code. The other one, no. The other one is a no-code experience. So right away, there's a big difference on that. So what supported language do you have on this? You might ask. Well, C#, JavaScript, F#, Java, PowerShell, Python, TypeScript. So all of those are supported languages that we have here. And as you can see, we don't have all the ones that are supported in the app service. So there's like slightly different languages that are supported on this versus the other, okay, which is fine. The major ones are here, so there's not a problem. Like I said, this is developer driven, so you need to write code, and we have multiple hosting options, so 3 to be more precise, which is the app service plan. That's the app service plan that we talk about. You just create an app service plan, you have that dedicated compute, that's your compute. So if you need to go beyond that, well, you just can't, unless, of course, you create scaling rules, and then you scale up to a certain limit, well, based on, of course, the limits that you set up on the scaling rules. But we can also use the consumption plan, and like we already kind of covered this. So using the consumption plan, we just pay for what you use, as the name says. And we also don't need to worry about scaling, okay? It will just scale. You might have to worry, well, what about if this, scales a lot, and then I will have to pay, a big bill in my Azure subscription? Well, you can put some limits on this. So you can say, no, you grow, but you don't grow more than this capacity. So that you can, kind of not have a big bill in the future. And then, of course, premium plan. Premium plan, I'm not going to enter into details, to be honest, is not the course for this, but it's a special plan that we have that also comes with VNet integration and some added new features that sometimes resolve some issues that the consumption plan might also have, like cold starts. You can also run your functions more time than just the 5 allocated minutes that you have. That you can even go up to 10, but usually the 5 is the limit that you have by default. And then, of course, you can code this directly from popular, code editors like Visual Studio Code. And functions is what we call stateless, running stateless services. But of course, if you want the stateful and you need a stateful function, you can also use that. But we need to go with durable functions. Durable functions, it is just an extension that we run on top of functions. Just a last slide here about triggers and bindings. So yeah, we have triggers. Triggers is what causes the function to run. Some examples will be like a storage queue trigger. So, there's a new message on that storage queue. Then, my function needs to run. And now, this is the beautiful part of functions. The coding needed for this is just declaring this. You don't actually write code to make this happen. You just declare, this is my trigger. A blob trigger, same thing. There's a new file, on that blob container over there on the storage account. Or there's an event grid event. Or, there's plenty of other triggers like HTTP trigger or a scheduled trigger. And then we also have bindings. So bindings is the way for me to declaratively connect with other resources. So they can be inbound, they can be outbound. And it's the same part, the same conversation. We don't need, to write code to do this. Imagine, I have a queue trigger and then in the end, I create a PDF. I generate a PDF. Now I need to drop that PDF in a blob storage account. I can just say, well, that's my output binding. And then just say, hey, this should go to my output binding. And I don't need to write the code needed, to take that PDF and write that PDF in that storage account, because all that code is already written by the platform for me. So I don't have to worry about that. So that's the beautiful part of functions. All this plumbing code to connect all this, it is already done by Microsoft. So there's no need for you to do anything on this. So now let's create some Azure functions and check triggers like HTTP, blob, queue storage. And we're also going to demo here some possible use cases when Azure functions can be used. So let's create here a resource. And what is the first thing that we need to create? So we need to create is something that we call a function app. So a function app, then it will have several functions inside, but we always need to do this first. So let's just choose a resource group and let's just say LinkedIn Lamo function. So let's see if this one is available. It seems to be. What is the run type that I want? I will go for .NET in my case. .NET 6, yeah, it is perfect. Let me just tweak the region to East US. And hey, what is the operating system? Because, this is .NET 6. I can choose Linux or Windows, but I'll go with Windows. That's fine. And what is the plan type? So I can choose consumption, functions, premium, or app service plan. Again, consumption, it is great. You can choose more options under hosting. This always needs a storage account. I'll just create a new one. There are lots of other options here on the top. I'll just go straight to review and create. This is just an overview on Azure Functions. You can find other amazing courses about Azure Functions. If you search for that, I have an Azure Functions course. So you learn more about Azure Functions there. This is just a small demo about functions. So now this is creating the functions app. So let's just wait. There you go. It is created. So let's hit go to resource. So this is my function app. Don't forget function app. So now we need to go to functions and we need to create a function inside the function app. So let's do that by hitting create. And we have several options now. What is the development environment that you're using? I'm just doing this in the portal, or I'm doing another editor, VS Code. You can choose all this. I'll go with developing portal. Again, this is a simple demo. And I have several templates that I have here. Those templates are based on some triggers already here, like an HTTP trigger or a timer trigger or a queue storage trigger. I'll just go, to be totally honest, to the HTTP trigger because it's just the simplest one to demo, and I don't need to create a storage account and then add blobs there or queues and add another message into the queue. So this is the one that is the simplest one. That's why I'll go for that. What is the name of this function? So I'll just call it LinkedIn Learning Demo Func, and I will hit create. So there you go. It is created. Let's just wait a single minute for this to show up. It usually takes a few seconds. There you go. So now that I have my function in here, I can just hit code and test, and you can see all the source code of the function in here. And this is really simple what it does. So let's just wait. It's always take that extra time when we're recording. There you go. It loaded. And as you can see here, so just some, usings. And then if we search the code, the only thing that we do is, we get basically a variable on the body called name. And what we do is we just output to the console saying yellow and then, that specific name that we have here. That's all. Okay. This doesn't do that much, but that's the beauty of the functions. We're not here to do exactly something in the demo because that depends on what you want to implement. But just explaining functions is really just this, There is an HTTP call. It's going to be a post. It's going to have a body. In that body, there's going to be a name and then some value, which is name. And then, I'll just put LinkedIn Learning, for example. And then what I'm going to do here is just going to output that in here. Of course, in the real world, hey, it could be a payload that could be like a customer, an order, a supplier, and then we needed to add that to a database, for example. And you just build an API with the function, which is quite easy, to be totally honest with you, to build something like that. So let's just go test and run this. So there you go. I'm doing a post, as you can see in the top. And then on the name, I'll go for LinkedIn Learning Students, and I'll just hit run. And when you hit run, you're actually calling this, by the way. Okay, so it's a real call. I got a response code of 200, okay, so that's always good news. And then I have this response content. Yellow LinkedIn Learning Students, this HTTP triggered function executed successfully, which is, as you saw, the previous message. That's exactly what we have there. So this is just a small, example on how to build functions, and this could be super useful. So all that plumbing code, like I was saying before, you don't need to do it. So that is done by the functions infrastructure. It's all done for us. Azure Web App is an Azure service that runs on top of the app service. It's used to run HTTP-based services like, for example, .NET Core app or just a standard .NET PHP app, or even like a REST API that could also be based in several different languages. It can even run Docker containers, can run on workers that can be Windows or Linux machines, and we can also create web apps based on templates. So there is a marketplace on Azure, the Azure Marketplace, where we have several templates. An example is, imagine, for example, that you want to create your own blog. So there's several blog engines or an e-commerce web store that are already just ready for you. So you don't even need to deploy the app itself there. It's also great for Visual Studio and also for DevOps integrations. We don't also have remote access desktop for the virtual machine instances, but to be totally honest, it is something that we don't need. And we don't want to be updating, thinking about infrastructure security. So all that, it is run by the app service team. So we don't need to do that. We can run web apps using several languages, and we have here, just some of them. .NET, .NET Core, Java, Node.js, PHP, Python, Ruby, Go. So there's multiple languages that are supported by web apps and to run web apps. So there's literally, a great support for Microsoft languages and frameworks, but also for other third-party languages and frameworks in here. So that's something that, it is kind of covered. All this service is also very scalable and also has a big high availability. So in terms of availability, there is an SLA of an uptime of 99.95. And we can also, in terms of scalability, we can host our applications anywhere in the Microsoft Global Data Center infrastructure. So all the Azure regions, because this is one of the core Azure services, and it's available in all the regions in Azure that are already in GA. GA, by the way, stands for General Availability. And in some tiers, or better yet, in a very specific tier that is called the App Service Environment, you can even scale this up to 100 instances. So, big scale here that we can have with this. That Visual Studio and DevOps integration that I was talking about. So as you can see here, I can just deploy projects directly from Visual Studio or Visual Studio Code. There is that integration. You have your project there, just deploy it directly. Of course, let's be honest, I don't want you to do it that way. I'm sure you don't want to do it that way. We might want to improve this by creating a DevOps approach, a DevOps environment, like using Azure DevOps or using GitHub. And over there we have DevOps pipelines or GitHub actions that can implement that CI/CD process, so continuous integration and continuous deployment. So now the big question is, okay, that is great, but how can I create an Azure Web App? So there are, several ways of creating an Azure Web App. You can just go on the portal, click, and bam, you have your Azure Web App created. That's a great way to get started, to be totally honest. I'm a huge fan of that. Also, if you just have, a one-shot thing to do, great, just do it that way. There's no need for spending time with any other way of doing that. But let's imagine, look, Thiago, I have to do this all the time. I want to have also this script in a way that if I need to do this again, next time, I can do it in a very quick way and even automate how I do this. Well, the Azure portal in that case is probably not the place for you. We can use this using ARM templates, using JSON or Bicep. I can also do this using Azure PowerShell or even Azure Bash, so Azure CLI. So all of those are ways to do this and to create this. And we have several demos now where we're just going through all the possibilities of creating an Azure web app. Let's create a web app in Azure. So I'm already in the Azure portal, and I just need to select create a resource. I will just type web app. I'll just search for web app, and there we go. This first option, let's just say I want to create the web app. Now I just need to select here the basics in the project details, in which subscription, and of course, in which resource group I want to create this. And I need to find a global unique name, because as you can see here, the name will be something.azurewebsites.net. So I'll just say here, LinkedIn Learning Demo Web App 1. Let's just see this is available. It is available. And then I need to scroll down a little bit more. What I have here is publish. What do you want to publish? Like I said, we can publish code or we can publish a Docker container. We can also do static web apps too, but in case of code, there you go. I have now the options to select, which .NET version I want to select, there is plenty of them like ASP.3.5, 4.8, .NET Core, or even just .NET. Okay, so I'll go for .NET 6, which is the long-term support one, just because this is one of the frameworks or languages that it is supported in both Windows and Linux. So I can now choose, hey, I want a Windows or I want a Linux. Basically, this will be the workers in the background that will run this. If you choose, for example, let's just go here for ASP.4.8, see, Windows now is the only option that you have available. Linux, it is grayed out because, we can't run this at all in Linux. Other cases happen that if I go, for example, for PHP 8.1, Linux is the only option now. And then you can tell me, hey, Tiago, but, we can run PHP 8.1 on Windows. Sure, but this is a decision that the App Service team made of only support this in Linux. So we also have those options. So always check this very, very well because you might have some surprises on this, and I don't want you to have those surprises. So I'll go for .NET 6 again. I'm just selecting here East US. That's the one that I want to have. And of course, look, I can now create here, hey, I want to create my Windows plan for this. You see, there's a new one. And of course, the pricing tier. I'm not going to talk about this. We already talked about the app service plans. If you didn't watch, let's just watch one of the previous videos where we cover that part. Under deployment, this is kind of a new feature that we have here, which is GitHub integration. So GitHub Actions integration. So this will write all the YAML file for GitHub Actions to actively deploy your application that you have on a repo on GitHub into this web app. So yeah, if you want to use it, use it. You also have other tabs here like networking where we can, just configure some more networking options. Also monitoring, I'm going to put this to no right away, by the way, but this here is an option for application insights. And application insights, look, don't get me wrong, it is an awesome service. It is something that I always have, yes, in all my production web apps, but this is just a first demo on web apps. So I'm just going to put that to no so that I don't have to create, another resource in here. So now this is basically creating the web app. So now let's just wait a little bit so that this deploys. And there you go. So this has been deployed. It doesn't take that long, just a few seconds. And there you go. Okay, we have here our web app. I can just, figure it out, some of the options in here. We're going to talk about some of them. And if I click browse, this is what you should see on your browser. Your web app is running and waiting for content. So, now, yeah, we just need to write some code, right? And deploy a web app. We also have some videos on that further on this course, so watch them closely. So let's use here an ARM template to create now a web app. So let's just click on create a resource, and we're going to use here a tool that's called template deployment. Under template deployment, you can just use the Azure portal basically to deploy ARM templates. So let's hit that create button. Let's scroll down, and we have this quick start templates, and there are pretty good ones in here already. So let's try to find one for, the web app. And as you can see here, there are several of them around web apps. So let's just use this to find here one that, kind of fits our needs. For example, this one here, web app with log analytics. This also creates a log analytics, but let's just use this one. I'll just click select template now. Let me create a new resource group for this. I will call it LinkedIn Learning Demo ARM. And if you want, of course, I can change here some of the parameters of the template. In this case, what is the region? the SKU name. This is the standard, so the S1 and some other parameters. Even if you want, on the top, you can click Add Template. You have access to the full template in here. And of course, look, if you scroll down, you can see here under Resources. So this is the first type, is this web farm that we have here. So type Microsoft.web server farm. That's the app service plan. Then, so this part here now, it's the Microsoft.web site. So that's the web app itself. And if you scroll down and down, you have here some configurations. Now you have some extensions, some more configurations. And if you keep scrolling down, this is the application insights, operational insights workspaces, okay, the log analytics. So imagine you don't want the log analytics. Okay, sure, just delete, okay, this part from your template and you should be good to go. I don't want this. I just want everything. So let's just press save. Let's click review and create. And after the final validation, let's hit that create button and wait for our template to be deployed. So this template takes, 1-2 minutes to be deployed. So if you try this yourself, just please be patient. Things are happening in Azure. It just takes 1-2 minutes. So let's just wait a little bit. And there you go. So now this is fully deployed. We can go to the resource group and we can have a look. We created an application insights, an app service plan, a log analytics workspace, and this is the app service. So this is our web app. If we click on our web app, there you go. It's in here. Of course, we can do all kinds of customizations that we're going to do in a further video. But if we just browse, we can just see that famous landing page that we have for Azure App Services. And there you go. Our web app is fully deployed. Still on templates, but another option to deploy an app service, as also other Azure resources, is instead of using the ARM template, the JSON definition, is to using Bicep. Well, Bicep, in short, allows you to create a template-like approach in a way more simple way of creating the templates. In here, as you can see, this is the Bicep template that we have. We just have like some parameters, and it's very descriptive what we can find here. Usually we always say that, Bicep is a little bit more human readable than JSON. JSON is more machine readable. But as you can see here, the line 3, we have a parameter called web app name. It's a type string, and then equals to something. That something is the default value that we have for that parameter. And then look, I have some more parameters for the location, the SKU, the Linux framework version, the app service plan name. If we scroll down on this, then as you can see here, then we have this resource. And this is where we are going to create the app service plan. And then, property value. And pretty much that's the Bicep definition. Then we have a second resource that we're creating in here, which is our web app. So that's what we're creating in here. And again, property value with all the values that we need to put on this. And this is it. This is our Bicep file. So now the big question is, okay, we have a Bicep file, Thiago. How do I deploy this? Well, there is plenty of ways to do that. I just use here Azure CLI. And what I'm doing here is just 2 lines of code. So the first line of code that I'm just going to run here in my terminal, is just, let me create a resource group. Just pretty simple with that name that I have there in that location, in my case, West US. The second line of code that I have here, and I'm just going to select that and just scroll to the right. I'm just doing AZ deploy group create. As you deploy, resource groups, pretty much the same thing. In here, what I'm doing is to that resource group, and that's a template file, main.bicep. And, when you push this, you're pushing the Bicep template nowadays into Azure management layer. And then the Azure management layer, then, it's going to be capable of handling that. So this is running. When it's running, let's just go in here and let's just see something very cool, which is, let me just go, to the Azure portal. and just check out under resource groups. If we already have the resource group, it's here. And, if we go to deployments, you can see the deployment running there. There you go. It is being deployed. And you can even click on the deployment name, and you can even keep up, with the deployment. Now, deployment in progress. And now, you can keep it up in here. Just like ARM templates. It's pretty much very similar in that way. Oh, look, it is complete if we just go now into our bicep here. So this is still running. Okay, sometimes that happens. So let's just wait a little bit for this to finish here, and then let's just see how it goes. There you go. So see here, everything finished. We have the result in here. And, if we go to the resource group, we should see now our 2 services in here. We only see the app service plan, which is normal. I just created this. There you go. Just hit refresh. Sometimes this happens in the portal. The portal takes, that extra time. But there you go. We have our web app in here. And of course, this is a brand new web app. If we just click browse, it's just going to show up. And there you go. So we have our web application just deployed. So let's create now web app, but now just using PowerShell. So if you see this, I'm just doing some variables for the web app name and for a location. First line of code here, real code, let's just call it that, is line number 9. I'm just creating a new resource group. Line number 12, I'm creating the app service plan, and it's just using the new -az app service plan commandlet. Then we need the name, we need the location, in which resource group we want this, and in which tier. So that's it. This is how we create it. Line number 15 is when we're creating a new web app. So that will be the new -az web app commandlet. That also requires a name, a location. Now it requires what is the app service plan. So yeah, okay, this web app will run in which app service plan, and of course the resource group. So if we just, select this and just say for this here, run, okay, this selection on the terminal, everything now it is running on the terminal, and yeah, we're going to check out that all this, it is going to be here. So now I'm just creating the web app. So usually the web app, to be totally honest, is what takes more time in all of this, but usually it's just a few seconds, to be totally honest. After this is done, we can check out by just typing basically web app name, so that we can get the web app name that was generated, because we had that my web app, but then I get random. Okay. And then we should be able to open the browser and, just check this out. So web app name. So there you go. We get this. And, again, if we open the browser and just do this like Azure websites.net, there you go. We should be able to go to the place. So let me just put Azure websites.net. There you go. Just takes a while all the time. There you go. Just the first call. And that's it. We are on the web app. So this is how we can create a new web app using PowerShell. Another way to create a web app is to use Azure CLI. In this example, what I have is the first lines is, just creating some variables. And then line number 8, I'm creating an app service plan. If I scroll a little bit down here to the right, you can see that I'm just doing the free tier of the app service plan. Then I'm just listing that app service plan and others that I might have there. Then line number 12, I'm just going to create the web app itself. As you can see, it's just very simple. It's AZ, web app create, and then the variables and values that we need, the name, the resource group, and in which plan do we want to, to create this. So if I just, select this and say, hey, run all this here in the terminal. So you're just going to see the execution of this is creating the app service plan, listing the service plan. Now is creating the web app itself. And then eventually, it's just going to list it, all the web apps. And of course, then just run that small curl command to see the output of the app service, so that we see that there is a 200 OK and it is going to succeed and is going to work. There you go. And we just get that HTML as a result of this, okay? So that's kind of the idea. If I can just do this too, which is if I just say, hey, like echo, and that part over there, you can get here the fully qualified domain that we have to run this. And, if we push a browser and we just say run this, you just see the same thing, but now inside the browser. And there you go. So we see very easily to create an app service plan and a web app just using Azure CLI. When it comes to scaling, the first concept that we need to understand is scale up. And what is scale out? So scale up is when we just want to change the tier of the virtual machine instance that supports our app service. For example, when we move from standard S1 to a standard S2. S2 has bigger machines, so machines with more compute capacity, more RAM, and we're just, changing that. It can also be from S2 to S1. That's also something that we can do. When it comes to scale out, so scale out is a different concept, is we still maintain ourselves in the same size of instance, but what we're going to do is we're going to increase the number of instances. So an example here will be increasing from 1 instance to 3 instances. But let's talk about some limitations when it comes to scaling, because it is really important for you to understand this. How many instances can I have? That's a big question in app service. Well, it depends on the app service plan tier that you have. For example, as you can see in this table, Basic only supports 3, and this does not support auto scaling. So like I say here in the table, this is only for manual scaling. When it comes to the standard tier, you can get up to 10 instances. And yeah, this one here already supports auto scaling as also, manual scaling too. Then we have Premium V2 and V3, which in V3 we can go up to 30 instances. And then we have also the isolated tier that can go up to 100 instances. So a really big number already of number of instances that you can have. In even 30, it is pretty good. So talking about auto scaling, I was talking about that. So what auto scaling is that I can scale automatically based on metrics or based on a schedule. I usually like to say you can scale, based on predictable load and unpredictable load. Because when you do for schedules, it's because it's a predictable load. Every day from 9 to 6, I will have more load. So in advance for that, what you do? Well, you just grab more instances and you just say, hey, I need to scale this to, let's just say 5 instances. But sometimes we have what we call unpredictable load. And when we have unpredictable load, we need to scale based on metrics. In this case, the load. And let's just say that the metric that you chose for this was the CPU usage. So what you do is percentage CPU usage by my app service plan. If it reaches 75%, I need another instance for this. So that's what you do. So that's the scale out, but you can also need a scale in rule, which is for you to have less instances. So never forget that. If the app service plan is, consuming less than, let's just say 35%, you just say, hey, I want to decrease the number of instances by the value of 1. So that way you're saving Azure credits for this. So that's also very, very important in order to do. Never forget that, because a lot of people, they create scale out rules, but they don't create scaling rules. Those definitions can be done by the Azure Resource Manager. So you can create a JSON template definition for this and deploy it that way. You can script this if you want, or you can just use the portal to define this. So all of those are options. So let's cover here scaling based on a metric. Like I said, we set up this at the app service plan. So let's never forget, if you have several web apps running in the same app service plan, they all going to be affected by this. So if you say, hey, this is going to grow to 4 instances, yeah, there's, all the apps running there now are going to have 4 instances. So watch out for that. And of course, we have some built-in metrics like CPU, memory, data in, data out, that are just there. You just need to use them. You just need to configure it. But you can also configure this based on external metrics, like, for example, a service bus queue message count, so the number of messages that actually right now are on that queue. And then based on that, you might get more instances or less instances, because imagine you have a workload that has lots and lots of messages and it's not handling them in a time-fashion way. Let's create more instances so that we have more compute capacity to process all those messages that are on the queue. The other one that I said is, the auto-scaling based on an instance count. So this one here, like I said, it is important. It's based on a schedule you just define here. For example, I just say, hey, I want 4 instances weekdays, so Monday, Tuesday, Wednesday, Thursday, and Friday, as you can see in the picture. Be careful with the time zone, okay? I already had several customers telling me, hey, Tiago, this is not running at the time that we defined. Only 1 hour later is that we get to this. Let's go to the time zone, and yeah, see here, you choose the wrong time zone. So just watch out for that. But yeah, that's what we have here. That's that on those, okay, days in this schedule, you're going to start with 4 instances. Of course, if you still have auto-scaling will still work on top of this. So that's something that definitely you can configure it that way. No question for that. Here, you can see another example of this, which is a condition that you're just saying that first, I have a first condition that says that I always have a specific instance count of 2, but then you have the auto-scaling condition of the, like I explained before. So at least that there is a minimal of 2, but then on those specific windows of time, so from 8 to 6 p.m., you're always going to have 4 instances. So this is something that definitely, we can do, and this could bring really big benefits because you're just paying those 4 instances during the weekdays during that time, because that's when you have the load. So that's really a money saver option that we have with this. Okay, so let's talk about scaling now. This is a web app that I just deployed. And if we see this, the pricing tier of this, it is a free tier. So if we scroll down, we always have 2 options when it comes to scaling, which is scale up and scale out. Scale out means, I'm going to have more instances. If I try to do that in here, you see that I can't do that, because the free tier doesn't allow to scale out. It's just not supported. But I can scale up first. Scale up is doing vertical scaling. So I can say, I don't want to be in the free tier like you see here. I want to be in a tier that will allow me to scale. So what I'm going to do is I'm just going for production, and I'm going for a premium tier. So I just click and apply. And now this is updating the app service plan to the premium tier, more specifically to the P1 V2 series. So that is the one that I've chosen. This will allow me to not only scale out manually, but also to implement something called auto-scaling. And with auto-scaling, we can just put rules on this and say, hey, grow the number of instances that are supporting my web farm based on the load that I'm getting in real time. So that's exactly what we're going to do. So let's go for scale out. And now you see that the design here changes. And yeah, I can just do manual scaling like you see. It's just a slider, you can go up to 30 instances. Of course, be careful because you're going to pay per instance. So yeah, just be careful with this. So I can just say, hey, I want 2 instances, and the only thing that you need to do is just press save. Okay, and then you get 2 instances. The app service comes with an integrated load balancer, so all that is, taken care for you. You don't have to worry about that. What about if I don't want manual scaling, but Thiago, I want to do the custom auto scaling? Yeah, that's the fun part. So let's create a custom auto scaling. And of course, look, all this scaling names here. You can tweak this. Please tweak this. Okay. Don't leave these as the default names. And what I can do now is, I can just say that I want to scale based on a metric, for example. And I can just click here on this very small link that says add rule. It's not the best, UI in terms of just figuring it out exactly where to click, but it's what we have. So if you do this now, there is plenty of metric names in here. Okay. I'll go for the CPU percentage. That's, the most common one, to be totally honest. But, it could be this queue length. It could be the data in or the data out. You just need to choose the best metric that fits your app. In this case, my app usually runs out of CPU first. So that's the one that I want. And if I scroll down, so you can see that it's like consumptions of 40-ish%, then it got lower. So let's just go with this and let's just say greater than, let's just tweak this to 75%. For 10 minutes, I want to increase the count by 1. So that means I'll click add. So what this means is in the last 10 minutes, if my CPU usage is higher than 75%, I will get another instance to my farm. We did the scale out, but we can't forget. We also need to worry about doing what? The scale in. So in order to do that, let's click add another rule. Same thing, CPU percentage, pretty much the same. But in here, in the operator, I'm just going to choose less than. Then you need to figure it out. What is the best number for your app? Let's just say 35 in this case. And then I'm not going to increase the count, but I'm just going to do exactly the opposite, which is decrease the count by 1 instance. And when you do this, there you go. We have created that scale in rule. So scale out, more instances. Scale in, we're going to have less instances. And of course, if we don't need the capacity to be available there, hey, let's just free it up. And of course, let's free up also Azure resources with that. So we also save money in the end. Then we also have these instance limits here. We can tweak this. For example, I can tweak this to, let's just say, a minimal of 2. I always want to have 2. Let's just say default also to 2. And then the maximum, okay, it's giving errors because the max here, let's just say 8. Okay, so there you go. So now we have there this definition here. So minimal 2, max 8, and a default of 2. So there you go. You just need to press save on this, and our auto scaling configuration, it's going to be saved. But you can even do something more into this. If we scroll down on this, you can add the scale condition too, and you can say scale on a specific count. Like, let's give an example here. That every day of the weekend in a certain interval, that you always need more capacity. So it's basically you're going to have a load that is an expected load already. So let's just go let's repeat for the specific days. I said the weekends. So let's just go Saturday and Sunday. And let's just say since like 10 a.m. until 6 p.m. Okay? So there you go. You can also do this. So this is for expected load. And the first one that I defined was for the unexpected load. So that we're based on the CPU percentage. So there you go. So very easy to set up scaling using the Azure App Services. Containers have become very popular. In Azure Web Apps, we can also run our Azure Web Apps deployed as containers. So we support Docker images. This still runs in a fully managed platform like Code Web Apps. We can still use all the scaling features that we have. And of course, we can still use all the CI/CD integrations from Visual Studio Code, Azure DevOps, GitHub Actions, where we can, of course, in this case, build our container images and then push them into ACR, so Azure Container Registry, or any other kind of registry, like, for example, Docker Hub. We can also run containers in both Windows and Linux, and we can deploy containers as just a single container approach, or using the multiple container approach using like Docker Compose. In terms of deployment, so if you're using Linux, you need to create your web app in a Linux app service plan. It used to have big catch here that you might still read about, that you need to have a Linux app service plan in a dedicated resource group. So that means you cannot have a resource group with both app service plans from Windows and Linux, but that has been changed at the recording of this video. That's no longer the right way. We can have now, both. But if you still have a resource group that was created before a certain date, that's still the case today. Okay, so just watch out for this. It might change in the future when you're watching the video, so just go and check this out. There's no shared tier available for Linux, so you only have free and then the dedicated tiers like basic, standard, premiums, etc. So the same applies, of course, for Docker containers if you're running them in Linux. And you can implement CI/CD processes using Docker Hub or Azure Container Registry like we saw before. But when you talk about containers, look, there are other containers services that are also needed to help with this, like Azure Container Registry. Usually it's your choice to host your container images. You push them there, and then when you want to deploy those images into Azure Web Apps for containers, you just pull the container image and you run that. If you need to run very short-lived containers, you might have a look at ACI, so Azure Container Instances. It's a great service too. Also, if you need to start to think about orchestrating, so doing container orchestration, AKS, it is the name in Azure, so Kubernetes. But also check it out, container apps. You might have a good surprise. Something that is still an orchestrator, but is way simpler to manage and also cheaper to run than AKS in some scenarios. Of course, I'm not saying that it's for all the scenarios, because of course it's not. But for some, just have a look at that too. Web applications need to store configuration data. The method on storing that will differ from platform to platform. For example, if we're talking about the traditional ASP.NET applications, they are normally stored on the app settings element. This is just something that makes part of the web.config file, which is an XML file for all purposes. If we're talking about a .NET Core app, well, we have, other methods like the app config file. But that's, the app technology, those platform technologies that they come with. When we are talking about the app services, we have ways to store all those configurations instead of, base this on text files that they are very easily tempered. We can store them as settings of the Azure resource. And then, because of that, we can use the Azure portal to change this. We can also use any other methods that can access the ARM layer, Azure CLI, PowerShell, well, you name it. It's also useful to store, like database connections and API URL or something like that, because, when developers are building the applications, they still don't know the production database settings or the, the third-party API URL for production use. Very important is, all this data can also be integrated with other Azure services, like, for example, Azure Key Vault, which is, I'm a huge fan of that, and usually that's what I use to store such important data. But even if you don't use the Azure key vault all the data that you store in the Azure App Services. It is encrypted at rest. So you don't need to worry about, that information not being encrypted because, it is encrypted. Also, if you use slots, this can be independent from the slot. So what I say is, we have a settings that it's going to be using all the slots, or they can be slot dependent. So in this way, I can just say, this database connection here is just for the staging slot. That other database connection is just for the production slot. So we have options with this. Also, we can find under the settings something called the general settings. So this is where, we can find settings like, hey, what is the stat setting for this? Are we using PHP, Java, .NET? Okay, what kind of .NET? Is it ASP.NET for 7, for 8, or are we talking about, .NET 6, or even just 7, or something in the future that will come up? What is the platform? 32, 64 bits. You need to have FTP settings for this app setting, for this web app. Well, yes or no? And if yes, you see also how do you connect via FTP to this? Well, I hope that you don't use this. It's definitely not a best practice nowadays. HTTP version. Do you want to support HTTP 2 on this? App settings support HTTP 2. So if your app can support this, great. And then, other settings like, are you going to allow communications using WebSockets to this app? Does it make sense for you? Always on, HRR affinity, remote debugging. If you want to, from Visual Studio, do remote debugging directly into your app, do you want to allow this? For production applications, well, for sure not. But when you're developing something, that can be pretty useful to use this. So this is, just some of the things that we can work out under the general settings. When we create an Azure web app, Azure provides a default host name that usually will be the name of the app, and then .azurewebsites.net. Well, most businesses, they don't want to run their web applications under this host name. They want to have what we call a custom domain name, like, mycompany.com. So for this, we can create custom domain names. We just need to run our web app in a tier that is not the free tier. So all the other tiers, with the exception of the free tier, they allow custom domains. If you're in the free tier, well, you just need to use something.azurewebsites.net. But to be honest, the free tier is not recommended for production workloads. So that's not a big issue with that. So if we want to use something like, let's imagine like linkedin.com, you need to implement a custom domains. This can be done. You just need to go to your DNS records for your domain, just add an A record or a CNAME record, and then you go to the Azure Web App, and there's an option for custom domains, and you just need to input your custom domain there, and then, that record will also serve as validation that you own the domain. And that's a very pretty simple job to do and to configure custom domains. And then, of course, after this, that's always another challenge, which is we already have custom domains configured, but let's configure HTTPS. So there's also something that we also need to set up, like TLS, SSL settings, so that we have a true modern experience for custom domains. So we can use HTTPS, then www.mycompany.com, something like this. But that's it. So basically, custom domains supported, all tiers except the free tier. So it's time to add a custom domain to our web application. It's really simple. So let's just check it out. This is my web app, AZ LinkedIn Learning. If I just browse to this, you will see here the Yellow World from .NET 6 app. It's just a standard sample app, but it will serve the purposes. As you can see, the URL of this in the browser is azlinkedinlearning.azurewebsites.net. Let's just be honest, it's not the best domain in the world. If I want to put this in a business card or, in some advertisement, something like that. And also for, customer trust in our organization. So for this, let's then add a custom domain. So let's go back here. Let's scroll down on all the options that we have here. And there you go. We have here an option that is exactly called that, custom domains. And it's really simple. We just need to hit this add custom domain button. And, we just need to say, this is all other domain services. Depending on, you can have an app service domain. If that's the case, there's a shortcut in here. And then, what is the domain that you want for this? And let's just say, I'll just go with LinkedIn learning.azcontoso.com. So I own this azcontoso.com domain. And it just kind of suggests me that, hey, look, you need to have a CNAME for this to point to that value over there. So I'm like, sure. Okay. So let me go to my DNS zone. And I also host the DNS zone of this in Azure. So let's just go with that. So azcontoso.com. And let me just add a record set for that. So this is a record set. So LinkedIn Learning, that the record type, like they said that, it's a CNAME. Let's go back to the custom domain. And then, I can just copy all of that that's over there to put it here as an alias. And then this is the first one. There you go. It's added. I also need a second record set, which is, for this part here. So let's just add that. And in this case, it's a text record. And I need to add this as the text record. So let's just see here, text record. There you go. And, I just need to add this value. I'm doing this in Azure DNS zones, but any other, DNS provider, it will be good. There's no problem with that. That's done. So let's get back to the add custom domain experience and let's try to hit validate. And, let's just see what happens. Everything went good here. Check, check. So we can then add the custom domain. And if we just wait a second for this, shouldn't take long. And, we should have our custom domain here. Now, it's basically just complaining about the lack of SSL, but we'll take care of that later. But for now, if we go to the overview blade and we try to browse now this, you will see that this already has the custom domain. So let's just try here. So it was LinkedIn learning.azcontoso.com. So if we try to do this, there you go. Complaining about, that the lack of HTTPS. Sure, we can bypass this. It's not good. For sure, we need to fix this, but just to prove the point of the custom domain, there you go. In a later video, we're going to fix this so that, that warning message, of course, doesn't show up because you just can't have that there. Your customers will not understand that for sure. So there you go. This is how you add very easily custom domain into Azure. So now let's talk a little bit about Azure Content Delivery Networks, Azure CDN. When I'm developing large-scale applications, performance and load times are really important in all this process of creating those applications. Sometimes we even spend numerous hours and even days sometimes tweaking applications to decrease in, the load time, sometimes in the order of milliseconds. Because all that is really important. This is where Azure CDN will help with the application performance because it will serve static content through a series of edge servers. So edge servers means servers that are near the edge, so near the user, instead of serving that content directly from my app that in the worst case scenario, it can be just in one data center. So that's basically the whole big reason of using Azure CDN. Increasing the application performance. In case of Azure CDN, we also have support for HTTP2. We can do content restriction by country. So I can say, I don't want to serve content to that specific country. Sometimes this might be useful. And we can tweak also how many days or what's the duration of that cached content on the Edge servers. There is, again, numerous optional configurations that we can do on this in order to tweak the caching. So that's basically for caching the content here. What more? So I can create CDN endpoints and then base that endpoint on an existing storage account. So I have a storage account, blob container, I put my content there. Again, centralized location because that storage account only exists in one specific Azure region. I can just say, well, through the magic of Azure CDN, this is going to be propagated through all the Edge servers, and then users can go to the Edge server that is closer to them. That's an option. We can also do other options. I can also create CDN endpoints based on a web app cloud service or even another public endpoint. It could be I just need like a host name. All this needs to be just public access. So that's the only caveat on this last options. And I can serve that CDN based also on custom domains. But we also have something on that in just a minute. So this is just an example, a graphical expression of what I was telling you about. Imagine there on the left, we have some static content stored on a storage account. This is a centralized location, is a specific region. Let's imagine a region in the US. Our client is in the UK. If my client needs to get access to that data, he needed to go all the way to the US. See, the latency on this will be quite high. This is why we created Azure CDN. And then we have this distributed around a bunch of Edge servers. Some of them could be Japan, USA, UK, Germany, just some examples. There are hundreds of them all around the world, by the way. So because this is in the UK, well, for sure, that's the one that's going to be selected. And that client just needs to get to the UK to grab the content. So as you can see, much quicker in terms of latency than going through the US. Imagine that this is not in the UK, it's somewhere in Australia, Asia. The latency even is going to be higher to go to the US. So having something more local, that's going to be impressively faster than not using CDN. So that's a big plus on using CDN. So we have a bunch of tiers with this. So we have Microsoft with the standard Microsoft tier. We have Akamai, we standard Akamai, and Verizon, that where we have standard and also the premium tier in here. Different features, different Edge locations. Usually, I sit down with my customers and we analyze what's going to be the best choice for us. Like I said, custom domains. So we can use custom domains at our CDN endpoint. The only thing that requires is to set up this is having a CNAME that points to the CDN endpoint. And then, of course, you need to verify that you own the domain. So there's a verification process. And we can also, in the Azure CDN, configure the Azure CDN for HTTPS. This will create a certificate for you. You don't need to bring your own certificate for this. And it's, built in. So there's not an added cost because of that. And you can protect this using an HTTPS and then a custom domain. And you're using Azure CDN to distribute your content. So very useful, very easy to do that. Also, a very important feature is called CORS. So cross-origin resource sharing. If you already develop applications that they need to, query an API, I'm sure you already come over this. So user agents on the browsers usually they restrict those calls, and CORS is basically a feature that allows cross-domain requests in client-side code. This is very useful for accessing blob storage, accessing APIs, and also, to access the CDN. So in here, you can just configure the CORS setting on your Azure CDN to allow, queries from specific endpoints, which will be your application. So from that application, you accept calls. From others, you might not accept that as an order to protect the content that you have over there. So that's it. This is basically Azure CDN, a very useful service to scale your applications to the global scale. So Azure Traffic DNS is a DNS-based traffic load balancer. This enables you to distribute traffic optimally to services around global Azure regions, while still providing high availability and responsiveness. Traffic Manager they uses is DNS to direct client requests to the most appropriated service endpoint. All this based on the traffic routing method and the health of the endpoints. Of course, if you have an endpoint that is no longer detectable, so not healthy, Traffic Manager will not route traffic into that endpoint anymore until it gets backed on as an healthy endpoint. Endpoints can be any internet-facing service hosted in Azure or even outside Azure. It could be other cloud providers. It could be on-prem, for example. Traffic Manager provides a range of traffic routing methods like, for example, performance and weighted or geography, where I can even tweak where to go based on the client IP address. Traffic Manager is also resilient to failure, including the failure of an entire Azure region, because Traffic Manager is what we call a global Azure service, so it is not dependent on a single Azure region. Service endpoints, like we see here, they can be virtual machines, cloud services, an app service, or, like I said, an external IP address. Some of the benefits that, we have with Azure Traffic Manager. Well, definitely improving the availability for critical applications that we might have. For example, if we have a application that is globally distributed around several Azure regions, if one of those regions is not available anymore for some reason, well, we still have the other Azure region. So this, of course, improving availability of that application as an overall. Also improves responsiveness for high-performance applications. So when you have those applications that you really need to have that very high performance, because, we have low latency if we use something like performance as the routing algorithm, because with that, what you're going to do is it's going to detect your IP address, and then it's going to route traffic to the closest Azure region that you have from your location. Also to perform service maintenance without downtime. So I imagine I have two regions. I have one app deployed in two different regions. I can do maintenance in one of the regions and then not having a downtime on my application, because the other region will basically load all the traffic by itself. Of course, we need to also have workloads there that they can be scalable, like, for example, the app service. We can combine on-prem and cloud-based applications. I basically have this in several customers where they have several Azure services acting as basically the backup for on-prem services. Also, to distribute traffic for large, complex deployments, something that I'm very fortunate to do in several of my customers, having those very complex deployments, and I have applications that they are globally distributed around the world. This is an example here of basically Traffic Manager. So we have our client. Our client is just going for, let's imagine contoso.com. So we have a CNAME DNS record for contosoweb.trafficmanager.net. That is your Traffic Manager service. So you get your Traffic Manager service. That will be number 3 here. And then Traffic Manager, in this case, we have 3 endpoints. So based on the routing algorithm that is configured, it's going to say, that's number 5 basically here, hey, client, you should go to that endpoint. That will be then number 6, where the client directly goes to the endpoint. So this is not like a traditional Azure load balancer or a traditional, application load balancer. Well, all the traffic goes through the load balancer in here. No, just this first call is done, and then we just do a DNS redirection for the correct endpoint. And then, all the traffic goes directly from the client to the endpoint until that TTL reaches its end. The time to live, that by default, by the way, is 30 seconds. And then, yes, then we need to do a second call to the DNS service and then to the traffic manager. And then we will get there again, eventually to the same endpoint or even to another endpoint if the conditions have changed. If we talk about routing algorithms, so this is just some of the methods that we have. We have priority, where we select priority when we want to use a primary service endpoint for all the traffic, and then provide backups in case that the primary is not working anymore for some weird reason. Weighted, we select weighted when we want to distribute the traffic across a set of endpoints, either evenly or according to weights, whatever you decide. And this is a weight. It doesn't need to be a percentage, by the way. So you could just say 10. And then when you add another one, you just say 10. And then you are evenly always distributing this with all the endpoints that you have available. Performance, one of my favorites. So we select when we have endpoints in different geographical locations and we want end users to use the closest endpoint in terms of lowest network latency. We also have geography. We usually use this so that users are directly to specific endpoints based on which geographic location their DNS query originates from. So this empowers traffic manager customers to enable scenarios where knowing the user geography region and routing them based on what is important for those users. So things like location of content, user experience, measuring traffic. So things like this can be achieved by using this. So just short explanation on the priority one. So this is priority. We'll get to the traffic manager. Traffic manager says, hey, go to priority 1. And that's it. All the traffic goes to priority number 1. If priority number 1 endpoint is not working well, then, traffic manager starts to redirect everyone to priority number 2. If priority 1 and 2 are not working, what happens is that, all the traffic then is redirected to priority number 3. So basically that's what's going to happen. What about performance? So performance, like I said, depends on the user location. So if the user is somewhere in the US, well, probably we're going to redirect them between those 3 regions to West US. That's probably the one that will be the closest in terms of network latency. If it is somewhere in South America, maybe South Brazil. If it is somewhere in Europe, maybe North Europe will be the choice for that. So basically, this is just a short explanation on how Traffic Manager works and how important and how useful it is for creating deployments in Azure. So it's time to demo here the Azure Traffic Manager. For that, I already took care of building here some infrastructure. I just created, as you can see here, 2 web applications. This first web application, it is hosted in Europe, and another one that is hosted in East US. So if we open the European application and we browse, you see there on the top, I just said West Europe so that we make sure it's this one. And you check the URL. It says aztm demo-europe.azurewebsites.net. If we go back and we open the US one, you will see that the URL is pretty much the same, but instead of -EU, it just says -US. And of course, the content of the app, just for demo purposes, is also slightly different. I just tweak it to say East US, so that this way we really know to which one we are being redirected. In the real world, usually the app is exactly the same. This is just for demo purposes so that we know, oh yeah, we're being redirected, to that web app or to the other web app. But now the idea is I don't want to give the URL for my European app or my US app for my customers. I just want to give them a URL. Just go there and check this out. Just one, a single one. So that is where, Traffic Manager it is a great fit for this kind of solution. So let's create a resource. And let's just push here traffic manager. Let's see what happens here. And there you go. This is exactly what I want. So let me create here a traffic manager profile. So the name of this, is really simple. AZ demo TM, for example. That will be the name, the URL, or the fully qualified domain name that you're going to have, azdemotm.trafficmanager.net. Big questions you might ask. Can I add a custom domain on this? For sure you can. But you always need to have this. Then I will just say here, performance is the routing method that I want. As we saw before, there are several of others, but in my case, that is the one that I want. And let me just place this here in this subscription and in the TM demo resource group. And I'll just press create. So now this is creating the traffic manager profile. It doesn't take that much time. Creating a traffic manager profile is pretty quick, as you can see here. What is the next step now? So the next step is I need to say that here under endpoints, that those two web applications, they are going to be the endpoints of this traffic manager. So let's just work out that. Let's just say Europe. Let's just say it is an app service, and under all my, app services that I have here, I want to select this one here. And this is for the European one. And of course, now I need to do the exact same thing, but for, the US application, the one that I have hosted in the US. So there you go. This is done. And now let's just call this North America and app service. And let's just go with this one here, AZ Traffic Manager Demo -US. And this way, we just have added those two endpoints. Now we just need to be a little bit patient because there's this monitoring status here. So the third column that you see in the picture that is currently saying checking endpoint. It needs to be okay. So it needs to be online, that part. So we just need to wait. Usually this takes like 2-3 minutes, and then it just changed the status for online. So let's just wait a little bit. So now that we have both endpoints as online, we can just move forward. So if we go to the overview blade and we copy this, let's just navigate to this. And the outcome, that I want with this, that I'm expecting, is that this will redirect me to the European version of the application. And there you go. See, West Europe. So that was the case. And why is that? Well, because I chose the performance routing algorithm. I'm based in Europe. So, this is the expected outcome. What about, let's just go here inside this virtual machine. And now this virtual machine, it's an Azure virtual machine that I'm hosting somewhere in the US. So if I just use, the same URL, the expected outcome in this case, as you can see, and of course, it is to do where is to go to the US version of this application. So there you go. Now you get why I put West Europe and East US there as text in the website, so that we really know that, it's really redirecting to that. Instead, we could always look at logs, but, just easier for a demo like this to do it this way. So that's the traffic manager and how easy, it is to set up the traffic manager in here. When deploying web applications into the Azure App Service, there are two protocols that we are able to use, the web deploy or the FTP protocol. Making use of the web deploy, it is a much reliable and up-to-date modern protocol. FTP is just a standard file transfer protocol. It is a great protocol, don't just get me wrong here, but it's just not the best when it comes to deployment of applications. Sometimes we still have legacy systems that they need the enablement of FTP in order to be able to do the deployment. So yeah, FTP, it is available on the Azure App Service and you can use it. If you're not planning on using FTP, just disable FTP on the web app settings of the app service. Another great feature that we have on app services is deployment slots, where I can just use them to create staging environments. But later on, we're going to deep on the staging slots part. And of course, I can always deploy from Visual Studio or Visual Studio Code to web applications. It is very easy. There are integrated tools within those applications in order to do the deployment. So we're going to also to check that out. I can also use Azure DevOps or GitHub or even Kudu to automate all the deployment process. I have to confess, definitely my favorites is Azure DevOps pipelines and GitHub Actions in order to do this. But of course, Kudu can also be an approach for this. Source code can be in several source types, like, for example, Azure DevOps repos or GitHub repos or even other Git sources. If we talk about the web deployment protocol, so like I said before, it really simplifies the deployment of the web applications because it provides this standard package format, Visual Studio, Visual Studio Code. If you do Azure CLI, all rely on the web deployment. And it is way faster than FTP, especially when we're coming into the redeployment of just changes, some fixes or something like that. Because FTP, you really need to know which files you have changed. You have to track down that. Web deployment already does that for you, so you don't have to worry about that. So talking about DevOps. So Azure DevOps, we can have what we call continuous integration and continuous deployment processes. We can work with any language platform and deploy this to the Azure App Service. And of course, other deployments to other components. So basically with Azure DevOps, I can automate the deployment of my web applications, since the part that I'm just building them and I'm just putting my code in a repository up to the point where I need to test those applications, making sure, they are secure. Azure DevOps, it's not just for Microsoft Azure. It can also deploy for other cloud providers like Google Cloud and AWS. They just come with support for all of that. I can also do NuGet and NPM public feeds. So you can also, with Azure DevOps, create a private feed that is NuGet compatible, NPM compatible, or when you're, building your application and you need to get some packages from NuGet, like from the public source of NuGet or the public source of NPM, you can also do that. And you have unlimited cloud-hosted private Git repos for your own project, so there's no limits on that. And of course, we have all the cool Git features like advanced file management, doing commits, pull requests, push, pulls, you name it. So all of that, it is there and it is supported by Azure DevOps. Now, just talking a little bit about CI/CD terminology. So we can have continuous integration, which basically we want to say is when we have code changes, there can be frequently merged into a master or into a main branch using then automated builds on that, and then, just build them, test them, and we can do that with continuous integration. If we're talking about the component that's called continuous delivery, so those code changes, they are built, they are tested, and then they can be automatically published to a test or staging environment. Continuous deployment goes a little bit beyond that. So those code changes that have passed all the processes listed above, now they can be automatically deployed into production. And this is the magic word here, automatically deployed to production. The automatically, it is the really important part. I have cases of processes that go from continuous integration, delivery, deployment that really, they just happen on a daily basis, several times a day. And the team is not looking at this 24/7. They're just a big confidence because of all the the work that has been done on that project, that everyone already kind of trusts on this. And I can guarantee you that there is no many failures on this. Many more will happen if you have manual processes being done by humans, because humans do a lot more mistakes than a process like this. So it's time to create here now deployment using the Azure CLI. Just, kind of one line of code if we see this. The rest are just variables here. Web app name, I just put the web app name that I already have deployed in Azure. I have this GitHub repo, which is a public repo. You can use this one too as a demo PHP app. And then the command is literally just this, AZ web app deployment, source configuration, that web app, so dash name, then resource group, the resource group that I have created for this, then, repo URL that you saw in the variable branch master manual integration. So, if we just send this here, this should, just deploy. So let's just now here wait for the outcome of this. So the deployment, it is running right now. So this should take a few moments. So let's just wait for that. And there you go. This has been deployed. So now let's have a look and let's check what have we deployed. So this is our web app here. Let's just try and browse this. There you go, Yellow World. So this is the PHP application that we just deployed, and everything worked, perfectly fine. It's just one command and you can do the integration on this. So very, very easily done. Okay, so it's time to deploy our application, and this time I'm going to use Visual Studio Code to do it. If we see here, I already have my app service. If we browse, just a standard landing page of this. If we move then to, Visual Studio Code, basically I already have here is a fully ready web application, one of those standard templates that .NET has. And, if we want to deploy, so Control-Shift-P to open the menu on the top. And, then we can just say, hey, deploy app services. And there is this Azure App Services deployed to a web app action. That's the one that I want to use. Let's just sign in into Azure. So with this, another window will open. I will just sign in with my credentials on the Azure portal. And when that's done, there you go. In Visual Studio Code, we have all my subscriptions. I will select this subscription and I will select my web app. So I had several web apps and now I'm going to do that. Then confirmation, are you sure you want to deploy? Yes, I am sure. And then this is basically building the app locally, and it is just deploying this. It's giving me some warnings here that I don't have the developer CLI and always deploy this. I can just say yes to that. And this here, if I wanted, I could just download this, but let's just choose later. Now it's deploying, so let's just wait here for a second for this here to deploy. Usually doesn't take, to be totally honest with you, doesn't take that long to deploy this, but it's an app. It just needs to upload everything into Azure, and there you go. It is done. So if I click browse website, so this is loading here. Let me just drag this here. There you go. See here, LinkedIn Learning, and if you see the URL on the top, it's our web app. If you really want to see this, let me just open the other page that I had. If I refresh this, see, there you go. It is our LinkedIn Learning welcome page here. So pretty easy, to deploy something via Visual Studio Code. Now it's time to demo how to deploy to a web app, but now from Visual Studio, so the full version Visual Studio. So we have here the web app, AZ LinkedIn Learning. If I browse this, there you go. You see just that standard landing page. So let's switch now to Visual Studio. I already have here my project. It is here. It's already open. And, you could just come here, code your way around this, just develop new features. And now you want just to test, just to demo how you can deploy this, directly into the web app in Azure. So we just right-click under our project, and we have this amazing option here called Publish. And to be honest, it's pretty much kind of just follow the steps here. It's pretty obvious, most of them. Where do you want to publish today? Well, yeah, Azure, that's the first one. So let's just select that and press Next. Then they just ask us here, which service do you want to publish in Azure? And we have several options here from the bottom. A virtual machine, a container registry, or an Azure App Service container, or container apps, or the Azure App Service, if it is based on a Linux workload or a Windows workload. In my case, I didn't show you this, but yeah, my app service plan is on a Windows service plan. So that's the one that I need to select. And then I can press Next. Then, it's just going to check here my subscription. I could choose, others if I wanted. Those folders here, they are the resource groups. So I have that web app here under this resource groups. I select exactly that and I just press finish. And when you do that, you download what we call the publishing profile. My question now is, okay, is it already published? It's not. It's just a configuration that, got downloaded. Now, you still need to hit the publish button here. And now the app is going to build locally. And then after it's being built locally, is then going to upload, all the files into the Azure Web App. And of course, this takes a few seconds. This is a very small application. It doesn't take almost no time building this locally, so it is quite quick to do that part and also to upload because, again, it's a small application. Sometimes if you have bigger applications, yeah, sure, it should take a little bit more time to do that. So let's just wait here a second for this to upload everything. So there you go. This says finish doing that. So if we go back here to this page and we just press reload, there you go. Our web app is here, okay, and it is fully deployed from Visual Studio. When you deploy your web app or API application into the Azure App Service, you can do this by deploying to a separated deployment slot instead of using the default production slot. What is a deployment slot? So they are live applications that have their own host names, their own app content, their own configuration elements. And then they can be swapped between another slot. So I can do like staging slot and then I deploy a staging environment there. I analyze it. I like it. And I say, I want this to go to production. Then with a zero downtime, I can just say swap this with production. And then, the new production will be the old staging. So that's a very, let's just say, important feature to make our solutions more resilient. Also, this works in Windows or Linux plans. There is no restriction on this. There is restriction in which tiers this works. So this only works in standard, premium, or isolated tiers. So if you try to do deployment slots, I don't know, like in a basic, free, share it tier, it will not be available for those plans. Talking about swapping the slots. So sure, this can be done very easily using the Azure portal. But let's be honest, if we want to implement some kind of DevOps approach to this, maybe you want to automate this. So yeah, sure, you can do this with GitHub, Azure DevOps, Azure CLI, PowerShell. So all of those are valid options for this. We can also define application settings to be what we call slot specific. So this is very useful. The example that I'm giving here is just like a database connection. Imagine I have production slot, I have the database for production. I have a staging slot, I have a database for the staging database where I have like some mock data, something like that. What happens is when you're basically swapping the two slots, you don't want that setting to go with a swap. So you don't say this is slot specific. So just don't say that. But sometimes, we have application settings that we really want them to go with the slot setting. Like you just change, for example, you're using a version of Node, the production is using a previous version of Node, and when you're doing the swap, you need to send this as an application variable. So things like this you can do, and you can just say, this is a slot specific value, and they're very useful for this. The swap process is done by just switching the routing rules for those two slots. And like I was saying before, this is very quickly done. And this is done by using almost zero downtime. What about benefits that we have with this? Well, validating the deployment. If you're using the staging slot, like I was saying before, you just move this into production. You just want to validate this. Making sure instances are pre-warmed before they are promoted to production. It's not the first or the last example of applications that goes to production, and then, the first users that are hit by the new deployment, it takes ages for them to load something because they are not pre-warmed. So that's just another example that adds a big benefit on this. And of course, just very easily to configure, you can just put this on your continuous deployment process. So all of those, they are great benefits of the usage of deployment slots. There are some settings that can be swapped. So like general settings, like the framework version, like that was the example that I told you, app settings, application strings, Handler mappings, public certificates, service endpoints, Azure CDNs. So all of those, they can be swapped. But we also have other things, that cannot be swapped even if you want to swap those, like publishing endpoints, custom domain names, SSL bindings, scale settings, IP restrictions, protocol settings like TLS version, for example, is one of them. And of course, course configurations. So all of those are things that you cannot swap. So just be paying attention to this if you're using app services slots, because you just can't use those for swapping. And of course, the best practices in all of this, always use at least one deployment slot for staging, and then, change your application deployment process to use that. Never deploy directly into the production slot. That's something. Even if that's really in your DevOps process, the last step, you never deploy directly into a production slot. You always do this for another slot, and then you do the swap on that. If you need, for some reason, to do performance-based testing on a deployment, so you create a slot, and now you say, hey, I need to do performance-based testing on this. Move that slot to a specific app service plan, because if that slot shares the same application service plan than production, well, you're in bad shape there, because production will be affected. And of course, we don't want that. So just create another app service plan, deploy there, create your testing plan there, do the performance-based testing, get the results, and then maybe you can just delete that. You don't need it to be there anymore. So it's just a few minutes, hours for you to do all the testing. And of course, this way you're spending more money, sure, but you're not affecting production, which I think the money that you're spending on this, it's not going to be that much when comparing to the effect of affecting production during those testings. So it's time to do a small demo here about deployment slots. We have this web application here. If we just browse to it, you just can see this demo web application. And what I'm going to do now is we're just going to Visual Studio and we want to do some code changes. So let's just change this welcome just to say like welcome LinkedIn Learning. And then we want to deploy this, but we don't want to deploy immediately to production. We want to test this out into like a dev environment. So for this, let's get back to the Azure portal. And under deployment, we have this option called deployment slots. For you to create a new deployment slot, it is really easy. You just need to hit the add slot button on the end and you just press the name here, just insert here the name that you want for that slot. In my case, I'll just call it dev. And as you can see there, the URL on the right is exactly the same, but then as that dash dev there. So AZ LinkedIn Learning dash dev dash the name of the slot. And then I will just press add. Now let's just wait here a second for this. There you go. It is successfully create. So if we now go to the dev slot and we hit the browse button here, you will see the traditional landing page of Azure App Services. So your app is running, waiting for your content, and this is the production one. So let's get back to this one here, and now let's go to the Visual Studio and let's do some code changes in here. So you don't need to be a developer in order to know this, but I'm just going to change, that welcome there. And I would just say LinkedIn Learning is enough. Okay. Welcome LinkedIn Learning. So just this very, small code change. And then I'm just going to use Visual Studio to directly deploy this into that slot. So in this case, I just need to press here, add Azure. This is very similar to what we did in a previous demo around deployment. So if you didn't saw that, just check it out. And I have here the web application that I want to deploy, but I need to still expand this a little bit further. And I have here deployment slots. And this is the trick here. You just need to select the deployment slot where you want to deploy. You hit finish. This will download the publishing profile. And let's not forget, now we need to press publish in order to then start the publishing, but now specifically for that slot. So now, the application, again, is being built locally, and then it's going to upload all that data into Azure, into that app service slot. So let's just wait a second for that to be finished. So now this is successfully finished. So let's just then go here to the dev slot and let's hit that refresh button. And you will see there, it's our website. It says welcome LinkedIn Learning. So exactly what we were expecting to have in here. But we look at this, we test, let's just, give that example. And we say, this is, exactly what I want in production. So how do you swap this slot with the production slot? Getting back into the Azure portal, what I'm going to do now is under deployment slots, I have another button here that says swap. So let's just choose that option. And what you have to select here is, hey, what is your source? What is your target? And that's what I'm going to do. And I will just hit that swap. In this case, this application, I don't need to worry about, other configuration changes. But of course, look, this is, definitely something that you should worry about if you want to swap those settings or not, because it will just tell you here source changes and the target changes. So you need to review this and make sure that, you're comfortable with those changes. So let's hit that swap button. And now this action, to be honest with you, takes a little bit of time in the Azure portal. Exactly in real world, this doesn't take that much time because this will be swapped way before the Azure portal tells you that it had finished the swap. But yeah, let's just wait here some time for this to be finished. So now the swap has been finished. So let's just close this. Let's go here to, this is the production website. So we don't have the -dev there. And if we refresh this page, there you go. So we now see the new version of this, or the updated version. And if we navigate here to, this is the developer staging slot. And if I refresh this, so like we saw, this is, the old production. There you go. So this is how deployment slots work, and just a kind of a first example. And it's how easy it is, to create a slot, deploy to a slot, and then swap the two slots. So now it's time to see how we can deploy this and also do continuous integration using Azure DevOps. So I have this Azure LinkedIn Learning app service. It's just a standard app service that I just created. If we hit browse, you see the standard landing page on this. So let's go and let's hit here Azure DevOps. So I already have on Azure DevOps, if we show here the repos, a full, web application here as a repo. So all the code of a .NET Core app. It could be, of course, Python, Java, whatever you prefer. I'll go for pipelines, and I'm just going to create a pipeline. So that's what you need to do. And in a very quick way, so this part, where is your code? It's in Azure Repos. This is the repo that I have. And, it just creates here basically all the code for me. If you see this, it has the publishing bits in here, and also it creates here also all the tasks to deploy this. If you want, you could just get in here, and of course, look, you can define here what is the name of the app service. I already defined all this previously, so this is why automatically shows up here. But, you could just tweak this. You just need to tweak what's the Azure subscription where you want to put this, what's the web app, it's a web app on Windows, and what is the service name. After all of this, it is done. Let's just hit run. This will create the pipeline, and it will just start to run this. First time, you need to go here under view, and you need to allow, the usage of that service connection, the service connection that allows me to connect with the correct Azure subscription. And now we just need to wait. So it's kind of the waiting game to get a host where we can just run this. It's already checking out the repo. It's doing the .NET build, and, then should very quickly do all the other tasks. So let's just wait here a little bit. Usually the task that takes a little bit longer, and because this is the first time that deploys, is the deployment, of the task to Azure. So we're still not there. So let's just wait a little bit then, and let's come back later when this is finished. There you go. It is done. It's finished. So it usually takes like 2 minutes and 10 seconds in this case. Usually it takes between like a minute, 2 minutes. It's usually the time frame for this. So if we get back here and let's just refresh this page. There you go. Okay, welcome LinkedIn Learning. So there you go. We have our website deployed, and you see it's really easy to do this. Now, and if we get back here to the Azure App Service, if you go under the Deployment Center, you can see there is an integration configured in here. Okay, so you see there, signed in, where's the repository, the build provider, you're using Azure Pipeline. So all there it's just set it up, also in here. So this also gets that information. And of course, if we get back in here, and if we go to pipeline, so you see my pipeline executed successfully. But if I go to repos, let's just go, for example, for pages. Let's just go here on the index page. And, let's just add another H2 on this. So let's edit this file. I already had this here ready. So let's just say Azure DevOps change, okay? And if I commit this, so I'm just committing this into the repo, you will see that pipeline. See, it's already executing. It's already queued. And it's going to execute because we also define this by default as continuous integration. So if we now, let's just this finish. Let's click here under jobs so that we can see all this. So when this finished, you will see that, the deployment will have this changed over there. So let's just wait a second for this to finish. So there you go. Everything is done. So see, this second execution only took 29 seconds. So really quick, right? So let's just go to this. And if we refresh this, there you go. Azure DevOps change. See, just a change that we did. And now, look, if your developers are just, pushing some code into this repo, this is always going to just automatically deploy. In this case, into production probably, but yeah, you need to tweak this in order, maybe using deployment slots, for example, so that you just deploy to a specific slot and not straight into the production slot. Of course, there's some improvements here that you can do this, but definitely is just pretty similar to this with just some tweaks. So now let's use GitHub to deploy an application and also implement continuous integration with this. So as you can see here, I have this AZ LinkedIn Learning app. And, if I open this, you see just the standard landing page from the app service. This is the repo that I've created. I just have here, just a standard ASP.NET Core application. We're going to deploy this using GitHub Actions. So we're just going to select here Actions. And we're just going to say here, okay, let me just search here for a setup. Let's just try to find here Azure. And if you find Azure, usually this is the first one, deploy a .NET Core app to an Azure Web App. That's exactly what I want. And we just download this. Then this is really simple because it's so easy because all the instructions are here. Okay, number 1, number 2, number 3, and then I don't need to read the instructions, but we just need to replace this, your app name, with the app name that we have. So let's just select this from here. There you go. And I need to replace 5 by 7.0 because that is the version of the .NET that we're going to have. There is still one other extra feature that I have to do. So let's just go with this. Let's just open here in another tab, which is I need to create a secret for my repo. So in order to do that, let's just go here with, secrets, actions, and we need to create here secrets. So first of all, we need to create an environment. And for that, let's just scroll down because they're going to tell us here what is the name of the environment. It's called development. And under development, okay, then I need to go secrets again. Let me then just create here a new repository secret. Okay, and this repository secret needs to be called what we had here on the top, which is somewhere near publishing profile. There you go. So it needs to be called this. And as the value, okay, I need to download the publishing profile and open this publishing profile. I can just show you there. So which is something like this. And I need to drop this in here and then add this as a secret. So there you go. It is added as a secret. So let's go. All should be done. So let's just start and commit. Of course, you should, give a proper name into this, but let's just go with this. And if we go to actions, so we can see here our action, okay, that eventually it will just start, okay, running. There you go. It's already here. So it's already now. It's queued. So let's just wait for this. There is your kind of two steps, the build and then the deployment. So let's just wait and see what happens. It usually doesn't take that much time, just like a minute or so. So let's just wait for that. So there you go. It is successfully. It just took like a minute and 22 seconds. See, like I said, not that much time. And if we refresh this, we should see here our web application. So let's just wait for this to load now. And there you go. So welcome LinkedIn Learning. There you go. This is what we have. Of course, look, if we go to our code, like pages, let's go here to index, not this index, but the HTML part of the index. So there you go. Let's just try to edit this. And let's just add here like an H2 like this. So just Azure DevOps change. Let's just say change to GitHub change. Okay. And let's just commit these changes. Okay. Again, I didn't tweak the names of, the commits, description of the commit, but there you go. So I already detected this. It's already queuing this, trying to find an agent where to run this, like a worker. Already found, so it's in progress. Building our app, and it's just going to deploy our app. So let's just wait and see the difference. There you go. We have success on this. So let's just refresh. And let's see if we have those changes or not. There you go. We have. So GitHub change. There you go. And it is done. So you see continuous integration in action. So now anytime one of your developers push new code into that repo, into that branch specifically, your GitHub action will just start and there you go. Things will just be deployed immediately. Let's have a look at how we can protect our custom domains with SSL TLS. If we just scroll down, we can see that this app service already has a custom domain. We previously configured this. This is the domain linkedinlearning.azcontoso.com, but we can see that there's no binding for this. So we need to add a new binding into this, and we can just select here as the source app, okay, service managed certificate. So that's something that, we can just create for this domain if we want, or, we can also say, and we can also use an existing one that we already have. In this case, we can import an existing certificate from the app service certificate, or we can upload a PFX, or even import some other certificate that is currently hosted on Azure Key Vault. So all of those, there are options that we have here. In my case, and let me open here another tab for this. And if we search for app service certificates, you can check that I already have a wildcard certificate here for the AZ Contoso, as you can see there, domain. So in order for me to do that, let me just go back to this step and say import app service certificate. And now I just need to select that one and I just need to press add, because this integration is just made already for us. So we just need to say that, yeah, this is how we would like to use this certificate. So there you go. Now all is done, all is taken care. The status, as you can see here, it is secure for that custom domain. And if we try to open this again, so you see not secure, but if I refresh this, or let me just open this in another tab, you will see that there you go. It is already secure. Okay, connection is secure. The certificate, it is valid. And, you can just check out here the details in general and also the details here about the certificate. So as you see, it is really easy when we have this app service certificates. If you need to upload a PFX, look, it's not that hard to. It is pretty much almost the same experience. Azure Active Directory is the evolution of Windows Server Active Directory. So the old Windows Server that we use on-prem, and we still have lots of companies using this on-prem. But Azure AD is the cloud identity service that we use for all the Microsoft cloud services, Azure, Microsoft 365, Dynamics, etc. Totally based on the cloud, runs on industry standards like OAuth 2, OpenID. So with this, we're just talking about industry standards, right? So basically everything that also follows those industry standards, they can use Azure AD as their authentication and authorization provider. Because we also have lots of open source libraries that can help us when we're building applications to build our applications and integrate our applications with Azure AD. In terms of authentication and authorization. So authentication is what we call the act of challenging a party for legitimate credentials, providing the basis for creation of a security principle to be used for identity and access control. In simple terms, it's the process of proving you are who you are you're saying. When it comes to authorization, well, authorization will be the act of granting to an authenticated security principle permissions to do something. It specifies what data, what areas of an application you're allowed to access and what you can do with it. So basically, this is the difference here between authentication and authorization. So, resuming, authentication is for you to prove that it's really you. Authorization is telling that, yes, you can do certain actions. You can access certain data. How do we start when we want to build an application to integrate with Azure AD? Well, we start by doing an app registration. So you need to register this in Azure AD. There is a very friendly UI that you can use to do this. There is two options that you need to select, single or multi-tenant. Single tenant is when you have an application that is only going to be used by the users of that Azure AD tenant. That's single tenant. And this corresponds to the great majority of applications that you're going to build, if not all, to be totally honest. When it comes to multi-tenant, so multi-tenant is when you have an application that you need to use in multiple tenants. A great example is, imagine I'm building a SaaS application. I'm going to have customers that they already have their own Azure AD tenants, and I want them to use their own identities to authenticate and then, of course, then authorize those identities into the SaaS application. That will be multi-tenant. So that's what you're going to write over there. The authentication process works something like this. Imagine I'm having a web application. I want to access my web application. My web application says, well, you're not authorized. I don't even know who you are. So, look, you need to go to the Microsoft Identity Platform because that's what I trust on, and you need to sign in. So you go there, you see the sign-in page, you sign in with the user that is there. All the sign-in process, it's taken care by Azure AD, so then you can implement FIDO keys, MFA, conditional access policy, passwordless approach, you name it. There's plenty of options out there, But then with that, you get a token, and with that token, you then can get to the web application. So that's the process for you to authenticate in a web application. What about App Service? App Service is an amazing service. We already covered it extensively in here. And you even have the option in a very simple configuration to configure authentication with Azure AD. Also works with other providers. It's not just with Azure AD. Also works with Facebook, Twitter, Microsoft consumer accounts, Google accounts. And all this, it's done by out-of-the-box configuration. There is no code needed to do this. And all the authentication and authorization models are going to run in a sandbox. So that's why you don't need to code for this. And so you can just put this in front of your web applications that you have that they were never configured to get this kind of experience, but now you're getting it by this token-based authentication configuration that we have from Azure AD. Okay, so it's time now to configure this web application with Azure AD authentication and authorization. In this case, what we have here is just a very basic web application. You see, just we click landing page, nothing fancy on this one here. And we're not asked to authenticate ourselves. This is totally open to the public. But if we want that, if we want to be needed to authenticate with a user that belongs to our Azure AD tenant, we can do this. We just need to go under settings. We have this option called authentication. And then under authentication, I need to select an identity provider. And in my case, like I said in the previous video, we have here several ones that already are here by default. I'm just going to say Microsoft in this case. Okay, I could also select if I wanted Apple, Facebook, GitHub, a bunch of others, but I'll just go with Microsoft. And I'm just going to say to create a new app registration with this name. Let me just add here some numbers in the end, okay, to make it unique. And then supported account types, I'm going to select this as current tenant. So that's the one that I want. And then, you just literally need to click add. There's some more stuff that you can do on this in terms of permissions, etc. Yeah, sure. Okay. But if you just do this, okay, if you just add, there you go. You have it here. It is done. It is configured. And now under overview, if we click browse, so the outcome now is that I'm going to be asked to basically just to authenticate myself on this application. So I no longer have access to this. If we browse this, okay, there you go. So this is the outcome that we needed. We're still loading something there. So if that happens to you, just need to retry again. So there you go. AZ LinkedIn Learning. Numbers that I put here. Hey, this is what I'm going to need to access from this. This is my account here. And if I just press accept, there you go. Okay. I'm now logged in. And of course, I get access to the application. So you see how easy this is with App Service. No code experience. And we got some authentication and protected our application with authentication. So now it's time to talk a little bit about backups and the Azure App Service and how Azure App Service deals with backups. So first of all, Azure App Service comes with built-in backups, so you don't have to worry about it. But this is a feature that is only available in the standard and upper tiers, like standard premium. If you were talking about standard, it will take care and will do 10 daily backups a day. Premium, it reaches the 50 daily backups. All those backups, they are stored in an Azure storage account, but it's what we call a managed Azure storage account because you don't see where this storage account is. You don't see it in your subscription, but it's a managed, Azure manages it for you. And there is a limit of 10 gigs for the app, and the database generates a zip file. And then through the UI, through Azure CLI, PowerShell, whatever, you can download, that zip file. This doesn't just back up the app itself. This creates a backup that bounds together that version of the code with that specific data. So that is, a very, very cool feature that we have with this. We don't only have the traditional backup, okay, but we can also have snapshots. And snapshots are automatically created, basically a periodic pre-store point of your app. This is only available, okay, in the premium app service plan. There's this small catch that we have here. And then we have, traditional backups. Yeah, we can schedule them. We can configure them. What gets backed up? So I told you it's the app, it's the data. So it's the app configurations, the database that is connected to your app, if it's one of the ones that you can see in here, like SQL database, MySQL, Postgre, or MySQL in app. So all this data gets backed up in this zip file. Then there is also a very cool feature that I love, which is called partial backups. Is that, sometimes you just don't need to back up all your data, all your app, because sometimes, there are some parts of your data that you clearly just don't need to back them up anymore because they are super old data. So with this, you have to configure partial backups using kudu and writing and editing the _backup.filter file. You can specify what is going to be backed up. If it's not in here, basically it's not going to be backed up. So in this case here, I'm doing the logo.png that is in the image folder, and then I have two other folders, 2010, 2011, that I also want to back up. So then this, of course, it's easier to get into that 10 gig limit that we have for this. So an Azure App Service environment is an Azure App Service feature that provides a fully isolated and dedicated environment to run your app services, but at a very high scale because, like we say here, it supports up to 100 instances instead of just the 30 that we can get with the standard app service. It also can host your Windows web applications, your Linux web applications. We can also have Azure functions, Logic apps, even Docker containers can be run using the app service environment. So what are the main reasons why we will go for the app service environment? Well, the high scale that we have, because, we can get that bigger number of instances. We can also, for high memory utilization, because we use virtual machines that have a better ratio when it comes to memory. Also high requests per second. So when we have this is something that also the A's will be a great fit. And of course, the big reason that most people will choose this forum, which is basically the isolation and the secure network access. So with the Azure service environment, we can have this network isolation that we can see here, where we can run like an internal line of business application, because we can have like an on-prem environment where we have express route configured or site to site, and we just kind of establish their virtual private network, so a VPN connection. And then this will connect to the internal load balancer for the app service environment. The app service environment is running in a VNet, so in the private virtual network that might not even have, network access to the internet. That's fine. We can put this to work. But if you want to use the app service environment and still have network access to and from the internet, sure, no problem, because you own the rules. You can say what he has access and what he doesn't have access. So that's a big advantage that we have in having this dedicated plan for this. Well, talking about plans, so currently we have two types of isolated plans. The isolated plan and the isolated V2 plan. So big differences that we have with one and the other. Well, there's one difference, and you can just see it here on the screen, which is V2, the virtual machines have more compute capacity. So more CPUs, more powerful CPUs too, and of course, bigger amounts of RAM. When it comes to another big difference that we have is the isolated, we need to have and we need to pay something called a stamp fee. A stamp fee is something that if you just have one instance and you just need to run like one application using the app service environment, it can be a blocker sometimes because of price. The stamp fee, it's not cheap. It is something that, in US dollars, it is something around 800 something US dollars in euros. When it comes to V2, so the V2 isolated, the instances, they cost a little bit more money, not that much more to be totally honest, but as you can see, the virtual machines also have more compute capacity. But a more important part, there is no stamping fee. So if I just have that one application that I need to run on this, clearly going to the V2, it is much, much cheaper. So that's just some of the differences that we have here with the plans. Okay, so what about monitoring? So we can monitor web apps, and this is one of those amazing features that we have with the app service being a managed service. So it's built in. You clearly don't have to install anything and connect this with some external service and configuring files and things like that we have done this for years and years on on-prem technology. No, it's a built-in feature. So we just need to activate what we want and just say, hey, you're going to, that log analytics workspace over there, and that's it. And some of the metrics that we are collecting are things like CPU time, memory percentage, data in, out, the average response time, and more. And of course, with all this data being collected, then maybe it's not a bad idea for you to set up some alerts. Like if something happens, I want to be alerted by email that this happened. But sometimes, no, I want to respond to this alert. So you might also consider to have, imagine a logic app or an Azure function or a workload on Azure automation just to respond to that specific alert. So, and because we have the data, yeah, sure, we can do this. It's a very interesting feature that we have with this. We also have logging. We can also have a built-in diagnostic data to debug our application. You have the web server diagnostics, the application diagnostics. And for example, if you're talking about .NET, you just need to write like system.diagnostics.trace error. And then, all this data, it's going to be on the application diagnostics. And of course, then we just capture the information produced by the web application. And then when you have the data, you can just try to understand what's happening with your application. In order to configure this and to enable this, like I told you, this is really, really simple. So you just need to turn the features on. And of course, over there, see, I'm just turning this on for the file system or on for the blob storage or the web server logging. And where do I want to put this? Okay, if you just say blob and you turn that on, that second option over there, something else will show up. And of course, you need to configure this to a specific storage account, but that's it. Okay. And of course, then you also can download the logs via FTP. So there's also another option that you have over there. So very simple to configure logs, and a very important feature, because without logs, without monitoring, well, when something goes wrong with our applications, we don't understand what's going wrong with our application. So it's really, really important to understand all this. Now that you have a look at how we can use Azure App Services to host HTTP-based applications, I encourage you to stay current. You can check other courses in the LinkedIn library about Microsoft Azure, and you can also check the Microsoft official documentation about Azure. And, now that you're comfortable with app services, start building amazing workloads. And you can even integrate app services with other Azure App Services and build amazing workloads for your users and customers to use. Thanks for watching.